Good morning. Not good morning. This is good afternoon. Queen's or King's birthday holiday. All right. We are going to do a set of questions on, again, equilibrium and rate of reaction because SAC is coming up, right? All right. Now, this question, as you can see, this question is based on rate of reaction. Now, what is happening in this question? We are trying to react zinc with hydrochloric acid and we'll be making zinc chloride and hydrogen gas. So how much hydrogen gas are we collecting? We are trying to find out the time it takes for us to collect 50 milliliters of hydrogen gas. That's what we are trying to do. Okay, 50 milliliters of hydrogen gas. So which one is our independent variable? Independent variable is the time. It takes for us to collect 50 milliliters of hydrogen gas. So that's the independent. Oh, sorry. No, that is the dependent variable. What am I saying? That's the dependent variable. That is dependent. Y-axis is dependent. So what's the x-axis? Independent variable is the IV is the temperature. So what we are trying to do here, we are trying to do this experiment in different temperatures. This is our independent. And we are trying to measure the time. Which is the dependent variable. Time is the dependent variable. And what are we trying to measure? Time it takes for us to collect 50 milliliters of hydrogen gas. 50 milliliters of hydrogen gas. Isn't that funny? I got the independent and dependent variable wrong. Sorry about that. You should not be getting that wrong. Okay. Now, okay. Let's see. Let's see what else is happening here. So 50 milliliters of hydrogen gas is the control variable. It's because you are always trying to collect same amount of hydrogen gas, right? Okay. Now, as you can see, when you increase the temperature, time it has taken to collect that 50 milliliters of hydrogen gas has decreased. You see that it is decreased? Yeah, it has decreased. Because you know that when you increase the temperature, rate of a reaction will increase. So rate is inversely proportional to the time. Higher the rate, lesser the time. Okay. What else? What I was meant to say, why is the rate increases when you increase the temperature of a system? Because you know that at high temperature, more proportion of the particle, you need to mention the proportion, more proportion of the particles will have energy higher than the activation energy. Yeah, don't just say kinetic energy will increase, therefore frequency of the successful collisions will increase. That is true, but according to the Vika, the main rate determining factor is the proportion, having a higher proportion of the particles which have energy higher than activation energy. All right? Okay. Let's go back to the question. Now, so this is our question. We know that independent, IV, this is dV. So what are the control variable? One of the control variable is the volume of the hydrogen. 50 milliliters should be control. And it says it's control. And also, what are the other control variable? Concentration of the hydrochloric acid should be controlled every time. Okay. All right. Now let's do this. I was saying, apart from the temperature, all conditions used in the experiments were identical, means controlled. Without referring to the zinc, you cannot refer to the zinc. State one condition, which would need to be identical for each of the experiment. In this case, as I said to you before, volume of the hydrogen should be fine. Volume of the hydrogen. Then the most important thing is concentration of the hydrochloric acid should be controlled. Okay, concentration. Okay, assuming the hydrogen gas is collected at SLC, calculate the minimum mass of the zinc that could be used in this experiment. Oh, that is a bit of a calculation question. Minimum mass. So what we do here, zinc HCl reacting with zinc chloride and hydrogen gas. So volume of the hydrogen gas is 50 milliliters. So at SLC, this is 50 milliliters as SLC. I mean, you must be collecting that. So you can find the number of moles of hydrogen. How? 50 N equals V over Vm. Yeah, 10 to the power 3, that's liters, and 24.8. Yeah, 24.8. 24.8. Okay. All right. What's the answer for that? Okay, then you can find the number of moles of hydrogen. They have used 24.5. I think it's 24.8. Well, have a look at the data booklet again, man. Yeah. So then the number of moles of hydrogen is 2.04 or 10 to the power minus 3. Maybe it's going to be a little bit lower than that, but you know what I mean, because they have used 24.5 in the answer. So that's the number of moles of sorry, it should be balanced. That's the number of moles of hydrogen. Now the ratio is also 1 to 1 because zinc to hydrogen is 1 to 1. Therefore, number of moles of zinc, not hydrogen here, number of moles of zinc has to be 2.04 10 to the power minus 3 times, that's the zinc, but the question is asking you mass. So the mass of zinc is going to be 2.04 times 10 to the power minus 3 times by 63.5 is the molar mass. 63.4. You should be getting 0.133 grams, or you might be getting something very similar to this, something lower than this amount, because I don't think they have had used 24.8. all right, but you get a calculator. I haven't got a calculator with me, sorry. All right, that part is done. Okay, next question. The experiment was replaced under identical condition except zinc granule was used. Zinc granule on the, okay, now here what have they used here? Without even zinc, this is zinc powder. So zinc granule, what happens when what do you think what will happen when zinc granules were used under the same condition? Granule powder will have a higher surface volume area. So high surface area of a powder is higher than the zinc granules, right? Granules will have lower surface area. So surface area is proportional to the rate of reaction. Higher the surface area, higher the rate of reaction. So because this is a solid, okay, no, you cannot say concentration because this is a solid. So you have to refer to the what? You have to refer to the surface area. Okay, in this question, since we are using granule, we will end up using more time. Yes, at 20, time will take more. So this, look, somewhere here, they are going to be higher, more. So it's going to be look like that. See that? Because for every temperature, you will end up using more time because we are using granules. So that's it. Okay. Then next one, in terms of the collision theory, what is the major reason? Now I've said that in increasing temperature. So what are the important things you need to say? When it comes to increasing temperature, you have to say kinetic energy of the particle will increase. Then more proportion of the particles will have energy higher than the activation energy. Therefore, frequency of successful collisions will increase. Is that clear? You have to say frequency of successful collision will increase, therefore rate will increase. Okay, all right, so that's what we did. How did you find that question? Not overly difficult question. This is not an overly difficult question, pretty straightforward question. All right, we'll come up with another question soon. All right, until then, Bye bye.